The video you're going to watch in a minute or so was made over the space of a few days. Now, while I did book a few results, there were also a few reversals of fortune, but all in all it turned out rather interesting. Still, I'm not entirely happy the way the video turned out, so I'll leave it up to you whether you want to spool forward to the bits you like or whether you want to watch the whole video. So, here it goes. Well, I hooked up the RCA to the isolation transformer and to my variac, and I'm getting ready to power it up for the very first time. Now, I'll admit I feel just a little bit anxious as to how the TV will react, but I guess if I monitor what's happening exactly with it, I can stop it from going into meltdown, so to speak. So what I did is I connected up 1 meter to monitor the current it's drawing on the AC side, so this, and I'm also going to monitor the B plus on this meter. Also, I connected up both chassis with an extra lead to be sure that there is a grounding between both. Now, I'm certain that there is a grounding lead, and in fact I think it's this black lead which does the grounding between both, but still it doesn't harm to take some extra precaution, and so I hooked up both chassis with an extra lead just to make sure about the grounding. Now, the first goal is to see whether all the filaments of all the tubes work, glow, and to see whether there are no obvious shorts or errors in the circuitry, which of course is always a point of concern the very first time you start up something you restored. So, without further ado, let's start it up and see what happens. I'm monitoring the voltage right here. Okay, so I should be getting somewhere in the range of 110 volts right at this point. Okay, so I did place the iron trap on the neck of the tube as well, although as we all know by now, it's quite likely that the tube won't work, or at least it won't work that well, if it works at all. So well, here we go. I'm going to connect it up to AC, and we're going to gradually turn up the voltage and see what it does. Okay, one moment. I really don't want to go too quickly with this because, well, we're playing with high voltage here. Well, actually, I should say, I shouldn't say play. We're dealing with high voltage here, and well, it's it's dangerous stuff. It really is. If you're not careful, you can get electrocuted, and well, aside from the fact that it would be very painful, it might also very well kill you. Okay, well, the meters are all hooked up. I'm all set. So, well, here we go. Okay, I'm pulling up the voltage now. I'm at about 50 volts AC. Okay, I can see some of the tubes glowing, and I can hear crackling coming from the speaker. So at first glance I would say that's positive. Let's pull up the voltage a bit more. Okay, I'm at about 80 volts, and it's drawing about half an amp current. The DC voltage is at about 157 volts DC. Obviously, I'm not seeing anything on the screen. Well, as I thought we wouldn't, but okay. Right now this is only a test to see whether there's no short circuit or anything. I can't see whether the diode tube doesn't seem to be glowing, but okay, that's possible. It's possible that it doesn't glow because there's not enough high voltage to power its filament, since the filament is powered by the high voltage coil. Okay, so let's pull up the voltage even higher. Here we go.
The emergency beacon you brought me will fire a distress signal deep into space, but it is damaged. There's another one in the tail section of our ship.
Okay, I'm close to 100 volts.
It's the tail, somewhere in this area. It's approximately 100 kilometers.
I'm not seeing any smoke yet, and I certainly hope not to see any. I can't say for certain whether there is high voltage or anything like that, but
You are going to retrieve
okay.
that beacon, or we are going to die.
Well, there is certainly sound coming from the speaker, so that in itself is a good sign.
I have to go retrieve the beacon. Or are we going to die?
You have air filtration inhalers. I need to take one now. The fluid
Okay, let's see what happens if I turn the
You have 6 buttons.
tuner,
Your weight, it should be 20 to 25
switch.
each. That's more than enough. Your lap suit and backpack are equipped with digital and virtual
Well,
reality, so I will be able to see everything that you see. And what
I
you
can
see.
hear crackling coming from the speaker. The current seems to stay at a stable 53 or 530 milliamps AC. So that seems to be okay.
Decision you make will be life.
Well, I can't tell whether the high voltage tube is glowing or not, but at first glance I would say it isn't. That's not a good sign,
No, sir.
at least for the high voltage it isn't. So hang on, let me check whether the voltage is at the right setting.
Hello, sir.
There are 3 possibilities. The first and most likely is that it died in a crash. The second and less likely is that it is injured very badly and still contained. The third is likely.
Okay, we're at full
Action is the worst case.
voltage, 117
The protocol is set
volts.
to evade. If he's out there,
Actually, I think I'm rather closer to 110, but okay, all the tubes seem to be glowing. All, that is, except for the high voltage tube. I can't really see whether it's glowing or not, but in my opinion it isn't. That's not such a good sign. Okay. DC voltage is right now at 227 volts, which is double what I expected. So maybe I made a reasoning error on that account. And the current draw is 660 milliamps or thereabouts.
Until she summoned Sif, power and shine. Sif banished all the grease to release any triple shine. It was always a beautiful ending with Sif, power and shine.
More like goodies. Delicious and 99 calories. 99 calories. More like goodies.
There's sound coming from the speaker. So the sound stage probably works. Obviously no picture. Well, obviously. It's not that obvious, but well, it was sort of, let's say, a vain hope to think that we would get any sort of image on this tube, but at least what we know now is that there's no short circuit. So that in itself is good. And the current draw stays relatively stable. Well, I would say it stays rock stable. It's at 660 milliamps, and the DC current or voltage is at 228 volts DC. Okay, well, for a first startup, this isn't too bad. It seems like I didn't make any obvious errors when I rewired and restored the TV, but obviously it's a little bit disappointing we're getting no image. Although, let's say it's satisfying to hear a little bit of noise coming from the speaker. Okay. Well, for let's say a first startup, I'm not too disappointed. Now, what we need to do is to find out why we're not getting voltage on the rectifier tube. It's quite possible the rectifier tube itself is broken, but there might be another cause. So, well, let's have a look. I'm measuring the high voltage at the tube anode, and as far as I can tell, there is maybe, I would say 1 or 2 kilovolts, perhaps a bit more, at the anode. So my guess is there is high voltage, although I can't see the filament of the rectifier tube, the high voltage rectifier tube, glow. But there seems to be high voltage. Not a huge lot, but there is high voltage. So that's, well, in a sense, that's a good sign. It means that the high voltage circuitry seems to work fine, albeit not very efficiently. So what I need to do now is to find out why the high voltage is so low, because according to the schematic it should be 6 or 7 kilovolts, not 2 or 3. So yeah, well, that is the next mystery I need to solve. And well, I need to do a little bit more reading to find out what could be the cause. Now, playing around with the vertical linearity seems to have an influence. So my guess is if I play around with all the other controls for the high voltage, I might be able to push up the high voltage to a level of, I would say 6 kilovolts, which would be good. Well, believe it or not, guys, I am getting something on the CRT. It's a very thin line and my camera is only barely picking up, but I think you can see it. So maybe there is life in the CRT after all. Now, like you see, the image is extremely faint and it's not very well aligned with the CRT. I think the yoke is in the wrong position, but the fact that we are seeing something on the screen is in itself something positive. Now, the weird thing is that the sound, for some inexplicable reason, seems to have an impact on the image I see. And that's mighty weird. I mean, can you imagine the sound influencing the image on the screen? I mean, that's mighty weird. But that's exactly what's happening. For some inexplicable reason, the sound seems to have an influence on the image. That's really weird. Okay, so, well, you might wonder, how did I get this on the screen? Well, I moved the ion trap around a little bit on the neck of the CRT. In fact, I tried to realign the magnet the way it originally was when I started disassembling the TV, and I placed the magnet, the ion trap magnet, more or less in the same position, and that brought into view this single white line. Now, as you can tell, it's very faint and it's just a single line. I can influence its width a little bit, but that's about it. So there's still quite a bit to do to get any sort of picture. Also, it's very, very faint. So that would suggest to me that perhaps the high voltage is very weak. And well, like I told you, the camera can barely pick it up. It's so faint, but I can see it quite clearly. However, like I said, I will have to probably move around the ion trap a little bit in order to get a better image or something like that. Also, the vertical deflection seems not to want to work. So, and that was originally the mistake, or rather the fault, the TV had when I bought it, namely no vertical deflection. So, obviously, replacing the parts in the TV did not have the desired effect of repairing the vertical deflection. That's not so nice, but okay, well, I think the fact that the TV seems to work and doesn't go up in smoke or anything in itself is a positive.